Hello, students. All right, so we're going to start with our algebraic expression or equations unit. And this is a little bit different than algebraic expressions, but a lot of it builds up. There will be new rules though that you will be learning about, and so we're going to cover these. So start off by this. I would like you to pause to begin with, and then I'd like you to copy this down. And we are going to fill in these boxes once you're done copying it down. So you could pause starting now. All right, so we're starting with this because I would like our definitions to be a lot clearer moving forward. So if you understand what we are talking about, then, or whenever I say something like constant, I hope you know that which one the constants are in the future. So the first one is, let's go with terms. All right, so the word terms is pretty much anything that is not an order of operation. So like these four are actually terms right here. And so what we're going to do is we're just going to write these four things down. So an example of one term is 2x, another term that I have is 4y, another term that I have is 6, and another term that I have is 7x. So in other words, anything that is not an order of operation. Okay, now what is a constant? A constant is anything that doesn't change. So there's no way of this number being different other than the number that it already is. So in other words, 2x, well, if you plug in something else for the x, then it's not going to be 2. So we can't say that the 2x is a constant. But the 6 over here looks like it's a constant because no matter how we change this equation, the 6 will still be a 6. So for a constant, I'm going to write down 6. So it is a term, but it's also a constant. All right, so what are the variables that I have? Well, a variable is anything that can change. So ideally, I can plug these numbers in or plug in a different number instead of these symbols. And the symbols that we're using are the letters. So the two variables that I see here, well, there's actually three that I see. So there's the x right there, there's a y right there, and there's an x right here. However, we have to keep in mind that if the x's are the same, like they're just x's, if I plug in like 3 for x, then it's going to go into any letter x that I see there. So in other words, really x counts as one variable while the y counts as another one. So one variable will be the letter x, another variable will be the letter y. So anytime I say variables, I'm talking about just the letter that we're looking at right there. And the last one are coefficients. Now these coefficients are the numbers that go in front of the letters here. So we could see that I have a 2, I have a 4, and I have a 7. These are all coefficients. So I could say, what is the coefficient for y? And then you're going to tell me that it's a 4. Now, when I am asking for coefficients, you just have to write down what that number in front of the letter is. So the coefficient, the first one is a 2, the second one is a 4, and the last one is not a y, but it's, a 7. So this is what we're going to start with, all right? So anytime you see terms, they are just like anything that's not a symbol pretty much. And then we have constants, we have variables, we have coefficients. Okay, so moving forward, now a word that we're going to use quite a bit is variable. As you could see here, the title is called isolating the variable. Now, what does it mean? Well, let's start with this. What is isolate? And I'm going to use this word quite a bit because anything you do at this point with the equations, with the equal signs, the goal is that we want to isolate. So isolating is when you have a variable alone on one side of the equation. So just to clarify, an equation is anything that has an equal sign. So this is different than expressions because an expression would be something like this, right? So here you actually have two expressions in this question right here. And how do you know it's an equation? Because of this symbol, because it has an equal sign. If you think about the word equation, it has the word equal as the root word, and that's exactly what it is. So let's talk about how we can do this, or why we would even do this in the first place. I'm going to give you a question here. X plus 5 is equal to 16. Can you tell me what is x equal to? Because it's a simple question, I do trust that a lot of you would already know that it is 11. And if you're not sure, about it, you could just remember that it's what is something plus 5 would equal 16, right? And so, okay, well, then I might have to take 16 minus 5, and that equals 11. All right. Now, the thing is, this works. This method of just kind of like intuitively figuring it out works with simple numbers like this. But eventually you're going to come up with more and more complex equations. So what I'm going to teach you is how can we find out what x is, or what is x is equal to, through this idea of isolating. So how do we isolate that x? And a key thing that we're going to have to remember here, or that you'll have to know, is you are going to focus on work, or when isolating, you're going to work backwards. So I'm going to start with this tip right here, because this is a key concept or a key step of what we're going to do. So you're going to work backwards, and that means like doing the opposite, which I'll show you in a bit. So here's another way to state this, but remember bed mass. Oh, actually we do PEMDAS here, my bad. Remember PEMDAS. But opposite. All right, so I'm just gonna leave it like that so that it's an easy, quick reference, and I'll explain to you why I wrote that and why we're gonna do that. All right, so let's try to look at the same question again, but this time we're gonna try to isolate it. And so instead of just jumping to the answer, we are going to use a couple of steps. So the idea is I want to get the x by itself. Now, if I were to, for a second, just ignore, don't cross this off, by the way, I'm going to use the color green actually. But if I were to cross off the 16 there, and I said, okay, I want to get the x by itself, what should I do? Well, right now, the x is accompanied by a plus 5. So I have to get rid of that plus 5. Now, I can't just like eliminate it, but here's the nice thing about having equations. The power of equations is that you could do anything to one side as long as you do it to both sides. So think about like your siblings, if you have siblings, right? Your parents could give you, I don't know, a piece of candy, but it's only fair if they also give your sibling a piece of candy. Or if they're going to take something away from you, then they should take it away from your sibling as well. That's what makes it fair. So I'm going to show you some steps, and I would like you to follow this. Now, this is important because when you show your work, I would like you to do this as well. So the first thing that I do is next to the equal sign, I will always put a line like that. And later we'll turn it into an arrow, but I leave it as a line because we might run out of space. I might need more space later on, so it's always good to just leave it open. Once you have this, then I want you to look at which variable are you trying to isolate. In this case, we only have one variable, which is the x, so I know that I'm going to isolate this side. So because of this, I am now going to have to work to get this x by itself. Now let's see, there's a plus 5 that's in the way. So how do I get rid of that plus 5? I have to subtract by 5, right? Because if something is adding 5, but then I take 5 away, then it becomes pretty much nothing. So now I'll write minus 5 because I know that that's how I'm going to get rid of the 5 there. And then I'm going to also, though, take away 5 from the other side. Because remember, the left side's going to say, hey, that's unfair. So the right side also has to reduce 5. Okay, let's see what happens here. Now, I'm trying to isolate the plus 5 and the minus 5. So what I'm going to do is I'm going to actually cross this off like that. because now I've just managed to get rid of that. So what am I left with on the left side? Well, I'm just left with x. What about on the right side? I'm left with 16 minus 5, right? Because there's 16 there and I'm minus 5. Well, what's 16 minus 5? 16 minus 5 is equal to 11. So I'm actually done with that. I don't think I could do anything else. So I'm going to do an arrow. I'm going to put the equal sign down here, right? Because I moved that equal sign down. On the right side, I have x. On the left side, I have x. On the right side, I have 11. And when you look at that, you see that, oh, that's a nice little answer there. X is equal to 11. Now, compare it for a second with this number that you found on top. You see how you're able to find the exact same number? Well, that is an example of isolating. So now you could do a couple more of these with a few different other examples. So I'm going to write down a few more examples here, and I would like you to just test these out just to see what we know. So let's say 3x is equal to 9. Let's try to see if we can isolate the x. So actually, I'm going to write example right there. So what do I do here? Well, the first thing I do is I draw that line. Always draw that line. I want to see that line. Now, this is 3 times x. So if I want to isolate it, well, it's x times 3 or 3 times x. So the way that if I want to isolate the variable, I have to divide, right? Because that's the opposite of multiplying. So if I divide by 3, please be careful. Don't divide by x. Sometimes people mistaken that. They divide by the x instead, which is not what you're trying to do. If you divide by 3, that should work, but I have to first of all remember that I'm going to divide it the other side by 3 as well. So now, if I divide 3 by 3, I'm left with 1. And really 1 means it's just nothing because 1 times x is x. So then I'm left with x on this side, and I could do the math here. 9 divided by 3, well, that equals 3. So then I close off the arrow, press equals, or add in the equals, and x is equal to 3. And that's it. All right, so now if I take a look at the original question, 3 times something equals 9. Well, yes, 3 times 3 is equal to 9. So I can definitely put the x as 3. Now let's try to go the other way. So now what we're going to do instead is let's have x over 2 is equal to 8. All right, what do I do? If you'd like to pause to try to answer this, you could go ahead and do it. And you could just hit play when you're ready. All right, so what I would do, draw the line again. If you didn't draw the line, you have to get used to that. And then now this is x divided by 2. So the opposite of dividing by 2 is multiply by 2. All right, so with that, I multiply the other side by 2 as well. Let's double check. So x divided by 2 times 2. Divided by 2 times 2, those are opposites, so I cross those off. Now I'm left with the x. On the other side, I have 8 times 2, which is 16. And so then I don't think I could do anything else with that. And so I'm going to leave it as x is equal to 16. And if you take a look at the original question, something divided by 2 is equal to 8. 16 divided by 2, yes, that is 8. So that is a little bit of the notes on isolating variables. And that's what we're going to put into our notebooks for now to get us started. All right, that's it.